Hey, what's up guys? In this video I'm going to show you how to use the ICloneable interface. So here is the ICloneable interface. It's very simple. It requires that you implement this clone method, and that's it, and it returns an object. So here is a person here that implements ICloneable. So we have two value types and a reference type that I decided to make string builder so I can work directly with it and show you what happens when you don't clone properly. When you clone something, you expect it to be completely independent from its origin. You don't want them to be like mishmashed together. So we have this toString here, so I can print it out a bit easier. You can add or override the toString method easily just for debugging by hitting Alt Insert with ReSharper and going down to formatting members and checking the properties that you want to create formatting members for. So here's an implementation of the clone method, and what I've done is I've used Memberwise clone. Memberwise clone will copy all the value types and the references of the reference types. So that's why I have this line down here so that I can properly make a copy of the reference type instead of just copying the reference to it. And that's what you do typically when you use Memberwise clone. You would want to use Memberwise clone if you have a clonable type that has a bunch of value types, whatever. I mean, you can use reflections probably and not have to use Memberwise clone, but I'm doing Memberwise clone here, and it's just the way I feel like doing it. Or it's a good way to depict cloning. I think there's also a serialization way that is completely separate from what I've just mentioned as well. It's worth looking into. So this is kind of unnecessary for a type this simple. You can simply do a new person is male. And this will work just as well. Alright, so this is a proper clone. So we're going to take a look at what happens in the program class. We have a person here, that's me, and I'm cloning person. So I'm creating a clone of myself, and then I'm replacing I with Y with the original person. Remember, this is a string builder, so I'm working directly with it, and then I'm writing out the clone. And you'll see that it doesn't affect the clone, and that's how you want it to be. So string builder is a reference type, and I've changed it because it really doesn't matter. I made a proper copy of it. So let's replace this here and just use Memberwise clone alone, and you'll see that it doesn't make deep copies of reference types. It just copies the references themselves. So when I replace I with Y in the original person, it changes the data that cloned is referring to when it comes to the name. So you can see, no, I guess not. Hold on. Oh yeah, it's because I have this line up here. So I'm going to take this this new keyword out of here. We're just going to pass the name in, and it should work like I want it to. So you can see that I has been replaced with Y in the cloned instance, and that's not behavior that you want when you're cloning. Well, you don't typically want this behavior. I have made a pretty sketchy clone method lately, cloning a rich text box for a multi-tabbed environment. It clones only what you would expect to be cloned when it comes to it being in a tab or multiple tabs. It doesn't clone everything, so yeah, you definitely want to comment when you do something like that, but I wasn't about to clone things like key bindings that aren't going to change amongst multiple rich text boxes. Alright, so that's it for the iCloneable interface. We are going to take a look at my ICloneable interface that I just wrote today, I thought it was rather odd how there isn't a generic ICloneable interface, because you're returning object here and you have to do a cast. So I created a generic one. I try to constrain it as much as I can. You can't fully constrain it, so that might be why it doesn't exist in the framework, or it just might be something lacking. I don't know. I'd like to hear your opinion on this. So here's my ICloneable interface. We've got generic type T, where T it has to implement ICloneable T. So this just means that this generic type has to implement this. So you can pass any kind of type in there that you want other than what's implementing the ICloneable interface, but typically it'd be very hard to make that mistake. You'll see why. Alright, so there it is. It returns generic type T. Let's use it. I would definitely do this if I have a project that has a lot of cloning. I'm probably going to actually use this in Notepad Enhanced or my extended rich edit stuff here. Alright, so we got generic ICloneable, and I've done something wrong. I'm not sure what's happening. So I'm specifying that I want the generic ICloneable, but this T thing doesn't exist. Probably thinks I want to implement this here because it's because of the signature of this method. So I'm just going to change this to person. Oh, what am I doing with my life? Okay, there we go. So person now implements ICloneable with the generic type person. So that's how I'm able to apply this. If I were to try to do it with other clonable types that implement the normal clone interface, it's not going to work because it has to implement this generic thing here. So you can implement this generic type or this generic interface on other types and then probably pass that type name into this, but that would be very hard. So this level of implicitness is, it's not a big deal. I constrained it as much as I can, and I think it's pretty beneficial to have this generic class for a multitude of clones. You don't need to do any casting. Anyways, just something to think about. And that's about it for this video. See you later.